Okay, so question 6 was about standing waves, and this question caused a little bit of confusion at the beginning, and I can understand why, but it's saying at t0 this is where the standing wave has currently been formed, and we can see that by this little line here. I've just put the little dot in to show where it's going to oscillate between. So at t is equal to 0, x is currently at this position. Okay, now at this point, this wave now, after this part, is going to start moving upwards into the highest part position up here. Okay, so in this case, therefore, x is actually going to move into the right. Okay, it's going to move up to the right, and then it's going to come back to the left until it returns to its original x position. So you've got a mark for recognizing it moves to the right and then back to the left towards its original position for 2 marks. The next one was giving you an equation that's never been used before, okay, but it's quite a simple equation. So it's saying c, which we know is the speed, is equal to root k over rho, and that's our density of air. Now, in this point, we wanted to work out what k is. Okay, so I'm trying to think, okay, well, I've got density, I haven't got c, so I need to work out what c is. So I'm going to use c is equal to f lambda. Well, I can work out lambda because that's not been given to me, but I have been given the length of the pipe. And if I look at the length of the pipe, I can see that the length of the pipe is equal to half a wave. Okay, so in this case, that's half a wavelength. So if my lambda, which is the length of the pipe, is equal to 1.4, my half lambda, so therefore my lambda is going to equal 2 times 1.4, so my wavelength is 2.8 meters. Now in this case, I simply just sub in with my frequency, so 120 times 2.8, which equals 340 meters per second. Now in this case, then I want to just resolve k, so I'm going to square it, and then multiply by density, which gives me 1.5 times 10 to the 5 kilograms per meter per second squared. The last one was then asking you to draw on to show that the image comes from the position indicated, okay, so from this image here. So what you always want to do with these questions is get your ruler, okay, and you want to connect your line, okay, drawing it from the position of the image, okay, to the wave, drawing it on, and then getting your line back to show that it's being transmitted from the transmitter. And what you should see here, okay, is that your angle of incidence is equal to your angle of reflection. Okay, so you've got a mark for drawing a diagram that looks like this. Okay, so I always find it easy just to draw from the position to hit somewhere else on the boat and then go backwards to draw it. And then the last part was, again, just explaining interference. So it says outline, why the observer detects a series of increases and decreases. So in this case, we're talking about maxima and we're talking about minima as the intensity receives of the boat along the line of XY. So again, we're saying we get an interference pattern, the waves are superimposing. I'm getting maxima when they are in phase, or they have a path difference of n lambda, and I'm getting minima when they are pi out of phase, or I'm getting a phase difference of n plus a half lambda.